gratings and high. Today, we are going to explain about the frictions on inclined planes. Before we get started, let's introduce our team who will be guiding through this topic. In this group, we have Shahril Nizam, Siti Nurshaliza Ayuni, Siti Nur Shafika, Shafika Sanif, and Tengku Lukman Hakim. All the group members will explain about their part. Introduction for the topic friction on the inclined plane. Friction is crucial when an object moves or tends to move on an inclined plane. The interaction between the object and the plane surface create frictional force that oppose motions. There are two types of friction relevant to inclined planes, which is static frictions and kinetic frictions. Static frictions prevent the object from sliding down when it is at rest. The maximum static friction force Fs is calculated using the formula Fs equal to nu s, and where nu s is the coefficient of static frictions and n is the normal force perpendicular to the plane. Once the object starts moving, kinetic frictions come into play. The kinetic friction force Fk is given by Fk equal to nu k, and where nu k is the coefficient of kinetic frictions. When analyzing equilibrium on an inclined plane, we consider both the gravitational force mg and the frictional force. The weight mg of the object can be resolved into two components, mg sin theta, which acts down the incline, and mg cos theta, which acts perpendicular in the incline. The friction force F will oppose the motion or impending motion. The maximum static friction force Fs can support the object up to a certain angle. Beyond this angle, the object will slide. Understanding this concept helps us predict and control the motions of objects on inclined planes, which is essential in many practical applications.
My name is Shahril Nizam and I will present about observations for friction on the inclined plane. First of all, the thing that we observe is the initial movement at lower angles. The block remains stationary until a significant force is applied or the angle is increased. This indicates high static friction at lower angles. And second, force versus angle relationship. As the angle of inclination increases, the force required to counter the block weight also increases. At high angles, the block begins to slide with less applied force. So the counter block weight is increases because the block begins to slide with less applied force when it is high angles. And last but not least, the static versus kinetic friction. Force required to initiate motion when it is on static friction is higher than the force required to maintain motion when the block is in a kinetic friction. To conclude, once the block moves, no additional force is needed to keep in motion. So that's all for observation. Thank you.
Now I will go to the result of friction on the inclined plane. Firstly, for test 2, the angle is 20, and then the applied force for P by experiment 0.7, by calculation 0.54, and the comparison is difference. For test 3, the angle is 0. The applied force from experiment is 0.9, and then by calculation is 0, and then the comparison is difference. For test 4, the angle of inclination of plane is 20. The applied force from the experiment is 0.9, and then the applied force from the calculation is 0.54, and the comparison is also difference. For test 5, the angle is 30, and then the applied force from the experiment is 1.1, and then calculation is 0.78, and then the comparison is difference. And the rest is still same. For test 5, the angle is 30, test 6 is 40, and then the test 7 is 45. Now I will go to the calculation for this experiment. Firstly, we must calculate the coefficient of friction by using equation for test 1. which is the result is 0.36. For number 2, in the case of angle of plane inclinations theta equal to 0 degree, calculate the value of the coefficient of the friction and the weight of block. um, the answer is 0. And then the last one is calculate the value of P for each including P at the angle of friction. For test 2 is 0.27, and then it's 0.54 is all.
Okay, my name is Shafika and I will be presenting about this question. First question, discuss the value of P obtained by experiment and calculation. Compare this value with the force S acting down the plane. There are slight difference in the P value obtained through experiment and calculation that have been recorded from the different angles, which is 0, 10, 20, 30, 40 and 45 degrees. The value of P obtained is higher than the force S acting down the plane, so that the block can move through the inclined plane. Okay, next, the difference between the experimental and calculated P value occurs due to various reasons. Is environmental error that gives a subtle wind effect to the mass and block. High wind speed causes the load P to move down at least precise time. Next is the wear and tear that appears on the block travel path. Therefore, to make the surface to the travel path smoother and be in the best condition to be used for this experiment, is the friction coefficient value are different. Finally, is the parallax error when the reading plane. This is due to the string not being completely aligned with the guide as it was previously prepared. The recorded angle may run and result in different reading. Lastly, the difference between friction on horizontal plane and the friction on the inclined plane are friction on the inclined plane had more friction than the horizontal plane. Moreover, the gravitational force of inclined plane is higher than the horizontal plane. This is due to gravity will be broken into x and y component when this happens to the force opposite, the motion will be trivial, thus contributing to the friction force. Thank you.
Greetings to Dr. Law and all group members. I am Senior Shaniza Ayuni binti Azan who would like to present about our question and conclusion. So the question is have two. The first one is, what is the connection between the angle of friction and the coefficient of friction? So the angle of friction and the coefficient of friction are directly connected. The coefficient of friction equals the tangent of the tangent of friction expressed as viscosity equals to 10. The angle of friction is the angle where an object on an inclined surface is just about to slide. It's the maximum angle at which the object stays put before sliding downhill. The angle shows how rough or smooth of the surface is contact. The second one is explain two engineering applications showing the significance of the friction on the inclined plane. The friction on inclined plane is crucial in two engineering applications, wedges and power screws. The wedges are tools with sloped surface used for splitting or lifting objects. Friction between the wedges and the object as well as between the wedges and the ground helps keeps the wedge in place and transmits force effectively. The angle of the wedge affects how much force is needed to move objects. The power screw is used threaded shaft to convert rotational motion into linear motion. Friction between the screw thread determines if the screw is self-locking, preventing the load from reversing the screw movement. The angle of the screw threads and the friction coefficient, a key factor, is how well power screw perform their task. So this is the conclusion. In our experiment of friction on an inclined plane, we found that increasing the angle increased the frictional force that matches our expectation and showed that the angle affects friction on inclined surfaces. we face some problems. Our measurements were sometimes inconsistent due to change in surface condition and how we placed the object. To fix this, we recommend keeping the surface clean, placing the object consistently, and doing multiple trials for each angle. This step will reduce errors and make the result more reliable. Using better tools like laser sensor and computerized data logging can also improve accuracy and efficiency. This will help us better understand friction on inclined planes and prevent uncertainty in future experiments.